This video is in response to a question from section 5.3 in our book. Again, chapter 5 is probability, and section 5.3 is focused on the multiplication rule. And this is one of those problems where you're asked for at least one. Okay, so reading through the problem, a test to determine whether a certain antibody is present is 99.8% effective. So this means that the test will accurately come back negative if the antibody is not present in the test subject. So 99.8% effective will accurately come back negative. So that's the probability of a negative test. So the next part says the probability of a test coming back positive when the antibody is not present, false positive, is 0.002. So that's the probability of positive for a false positive. So what is the probability that the test comes back negative for all 7 people? We have 7 randomly selected people who do not have the antibody. So that means what's the probability that the test accurately determines that they're negative? So that's that 99.8%. And so the first thing we have to do is think about whether or not these tests are independent. So does a negative test result on one of the people impact the test result on the other people or not? And so if you think about it for a second, these are individuals. The tests don't interact with each other in any way. So these tests, these 7 tests, are independent. And so that's the first thing we have to determine with this problem. So since they're independent, what that means is that the probability of having an accurate test in the first one is going to be the 0.998. And if I want to know basically the probability that all of them are going to accurately predict the negative test, I'm doing and for each of these. 1, 2, 3, 4, 5, 6. So that means it's the probability of the first one accurately predicting times the probability of the second one times the probability of the third one, etc. All 6. No, not copyright. Second one. Oh, it's so unhappy. Whatever. Okay. So what is the probability that the first one is going to accurately measure and say they are really negative? It's 0.998. So all you have to do is take 0.998 and multiply it 6 times. So it's actually in your calculator you would do 0.998 raised to the 6th power and calculate that. So for this problem, I don't think that's actually right. Let's double check that with an actual calculator. So I'm going to show you the Desmos graphing calculator because this calculator is what I use for probability calculations. So I'm going to show the Desmos calculator, and I'm also going to show how to use it to do probabilities. Now, one thing I will say about this calculator, it's a graphing calculator, but you don't actually need the graph for what we're doing with these probabilities. So I'm going to take 0.998 and raise it to the 6th power. Oh, that is right. 0.9880598. Okay, so that's the first question answered. The probability that the test comes back negative for all 7 people is that number. Now, what about the test for at least one of the 7 people? So these at least one problems basically require you to do a trick. Because at least one could be the probability that 1 is correct and 6 are incorrect. Or 2 are correct and 5 are incorrect. Or 3 are correct. So that's a lot of problems to do when it's at least one. But so there's a trick. And so the trick for at least one is to remember the complement of the complement rule. So for the complement rule, we have to consider what we're talking about. So the probability of at least one of the 7 tests comes back positive. So what would be the complement? What is the opposite of that? And the opposite of that would be none of the tests comes back positive. Okay, so none of the tests come back positive. If we think about that, how does none of the tests come back positive relate to anything that we're doing? Well, so none of the tests come back positive is the same as saying that all tests are negative. So we already found that all tests are negative from the previous problem. So let's come up here and be clear that this is the complement. And so how does this help me? We can use the complement rule. And the complement rule says that probability of an event is equal to 1 minus the probability of its complement. So if I want to know the probability that at least 1 is positive, then that would be the same as 1 minus the probability of its complement, which is none positive. And we can also write that at least 1 is positive is the same as 1 minus the probability of all negative. Okay, so this is the one that we're going to use. So the probability of at least 1 being positive is the same as 1 minus the probability of all of them being negative. So we can do 1 minus 0.9881 and get our answer. So that is the probability that at least 1 is positive. One final comment on Desmos, just to show the permutation and combination formulas in Desmos. If you're asked to calculate a permutation or combination, you can use your graphing calculator or you can use Excel. You can also come in here into Desmos and click on functions, and there's statistics functions in here. There's actually mean and standard deviation and all of that. But there's also probability. So here it is, down here in number theory. There's NPR and NQR. So N is permutations and C is combinations. So you can calculate permutations. Oops. And when you do it, it actually tells you what to put in the parentheses. The first one is your N and the second one is your R. And it'll just calculate it for you. So take out of 12 items, 2 is 132. And that's the number of permutations. Okay, I hope this helps.